Algebra students, this is our introduction video for our lesson on features of graphs. The next 3 lessons in this unit, we're really going to be focusing in on graphs of functions. And so for this introduction video, we are going to be using this graph here and the story over here that says the graph to the right shows function f, which describes the start of Janet's walk to school. Her distance from home in meters is a function of time in seconds. Now, before we look at any math problems, I've given you a story. We're talking about functions. What do I want you to do first? Label input and output. Go ahead, pause the video, and do that now. I've highlighted and underlined 2 different ways you can identify input and output. We've got those words is a function of, and so we have learned what comes first in that sentence is always your output. Also, whatever's on your y-axis is always going to be your output. Since we have a graph, we can use that information. And then the second part in that sentence, that would be our input, or our x-axis on our graph would be our input. So we've got this story, and it's describing how far Janet is from home, her distance, as time goes by. So we're looking at the first 120 seconds of her walk, or the first 2 minutes. This first part, using this graph on the screen, we've got these statements over here, and we are looking for which statements do we agree with. You've seen this in a couple past lessons and assignments, so I would also encourage you, pause the video and try to do this one now. I went ahead and put some things on the screen that might be helpful for us. We've got, when you're looking at function notation, what's in your parentheses is always your input. Here it's going to be what's on our x-axis, which represents time. And then what comes after that equal sign is your output. We're going to find that on our y-axis, and it's going to be describing distance. This is really helpful when I'm looking at these statements. For example, part A is saying f of 10. And so I'm looking at 10 on my x-axis here, a time of 10. And this is saying Janet at 10 seconds is 20 meters from her home. So when I look at the graph, that is this point right here, and so we agree. The next one is got those numbers flipped, so it's saying at 20 seconds she's 10 meters from her home. That I do not agree with. Part C says her distance 40 seconds from her home. So let me find that on our graph. 40 seconds is right here. So we're talking about her distance at this point. This in C says her distance 40 seconds in is less than 100 meters. Well, looking at our graph, her distance at 40 seconds is 80 meters. That is less than 100 meters, so I'm going to agree. These last 3 statements here have the function notation on both sides of our equations and inequalities. So for these last 3, when I read this, I'm reading it as her distance at 70 seconds is equal to her distance at 40 seconds. This is not saying her distance equals 40 meters. It's just saying these times have the same distance. So when I look at our graph, let me use a different color for these. At 70 seconds, her distance is right here. It's 40 meters. And at 40 seconds, her distance, that's that point we were looking at earlier, is 80 meters. Those 2 points in time, 40 seconds and 70 seconds, they do not have the same distance, so I do not agree with that. But something like E, this is saying the distance at 100 seconds is equal to the distance at 120 seconds. At 100 seconds, her distance is 160 meters, and at 120 seconds, it is the same. Her distance didn't change right there. And so I do agree with E. That last one, I think it should be an F, which is fine. But that final one is saying her distance at 50 seconds is greater than her distance at 70 seconds. So if we go to 50 seconds, let me use a different color one last time. At 50 seconds, her distance is right here. At 70 seconds, her distance is right here. And so I do agree. At 50 seconds, her distance is greater. This second question here is going to be easier now that we've already talked through what each of these statements says. The number 2 says find f of 30. So we're going to find what that output is, and then what does it mean in the story. Well, f of 30, we keep saying that this number here is our time. So I'm looking at 30 seconds. 30 seconds is right here. And so our output is 60. So I could say f of 30 equals 60. And what does that mean in the story? Well, 30 we already said is our time, so we could say after 30 seconds. And then that 60 is her distance. So I can use the exact words from the story or the graph. We could say after 30 seconds, her distance from home is 60 meters. Or you could say she is 60 meters away from her home. There's one final one here. This one says solve the equation. We are trying to find what number x would be. I'm going to scroll up to that graph and let you try this one. So you're solving f of x equals 120. Using this graph, see if you can figure out what x equals. Pause the video and do that now. So in this final question here, instead of giving you the input, I gave you the output, which means I gave you the distance. So looking at our graph, the distance is 120. We are trying to find the input. We are trying to find the time. At 120 meters, here it is, she is 90 seconds into her walk. So for that final one, I would say x equals 90. In today's lesson, we're going to be focusing more on graphs of functions and specifically what these different features in the graph can tell us about the story. And we'll talk about what those features are in the lesson. Hopefully you found this helpful. Thanks for watching.